So welcome Shivam Patlekha. Today is the seventh session. So today we will going to solve assignment number 2. In the last lecture we have solved first and first question and second question. Okay. Now coming back to question number 3. Oh, okay. So I'm recording the session. Okay. So let's start from this. Hmm. So the question is for the same figure as in the previous question. So previous question, okay, this figure CO3 minus. So it was like C. So this was your 1, 2, 3 and 4. 1, 2, 3 and 4. 4 is your carbon atom. Okay, so now for the same figure as in the previous question, the transformation matrix for S3Z. So what will be the operations we can do for S3Z? So should be C3Z followed by sigma x by, yes. So let's try to find out first this C3Z. Okay. So along, so in the previous, okay, X, Y and Z. So it was like this. This is your Y, this is your X, this is Z. Okay. So now along the Z direction, see, look at this figure. So this is your planar molecule, right? This is your planar molecule. So Y is, this is X, this is Z. So your Z is above the plane. This is your planar molecule. Z is above the plane. So along the Z direction, you are rotating your molecule by 360 divided by 3, 120 degree. Okay, now what will happen after rotating this molecule by 120 degree? It will going to change its position. So what will be the new position you will get? The molecule will get. So this should be 3, this should be 2, this should be 1. Okay. So if you try to find out the matrix for C3, what will it be? What it will be? See, let's say X, Y and Z. Now new coordinates are X dash, Y dash and Z dash. And these coordinates are, let's say, these coordinates now here. Like I'm saying this is as in the previous, these were the bases, PZ1, PZ2, PZ3. So pz1, pz2, pz3, pz3. Now after this operation, pz1, this one molecule came here. So what will it become? pz3. And what happened to this 2 atom, oxygen atom? It went to position where one oxygen 1 was present. So pz1. Now rest would be, and this 3 went to position 2. So z2. Accordingly, you can design your matrix. Okay. So just now in the place of 1, 3 is coming. This atom 3 came. So what will be your first row? 0, 0, 1. And for this row, 2 atom, atom number 2, oxygen atom 2 became oxygen 1. I mean the position has changed. So 1, 0, 0. Next, this was 3, became 2. So 2, I mean 0, 1, sorry. Should be 1. So this is your C3Z transformation matrix. Okay, now okay, now what will happen? Sigma xy. Okay, so xy is in the plane in which your molecule is lying. So tell me, what should we do now? Any one of you? Okay. Don't go. Okay. This is too bad. Whatever I wrote, it went. It gone. Huh? Anyways. Anyways. So answer is C. So our transformation matrix was 0, 0, 1, 1, 0, 0, 0, 1, 0. If I remember correctly, this is C3Z, and then we have to do this operation sigma xy. So basically, this plane Okay, okay, okay. That is why. Okay, this is here. The bases are these uh, these p orbitals. So what will p orbital is like this, right? Plus minus. So in this here, all of them are in the xy plane, but they are like uh, below the plane and above the plane. So if this xy plane will be there, if you operate this sigma xy plane, then all the lobes will change their position. What will happen? Minus here plus here. So simply this will transform to 0 0 -1 -1 0 0 0 -1 0. So this is your S3Z transformation matrix. So which one is the answer? I think C is the answer, right? Okay, C is the answer. Now, Shivam, Patlekha, did you guys understood? Okay, then moving to this question. So for any D2H molecule, so D2H molecules means we have C2, two C2s, at least two C2s which are perpendicular to each other. So let's draw a planar molecule. Let's say, this is your A, B, C, D, E, right? So the point group will of this is planar. So the point group of this molecule will be D2H. Okay. Consider the principal axis along to the Z direction. Okay. This is your Z XY. Using the unit vector along the three Cartesian axes as as basis, means bases are X, Y, Z. I mean the coordinates. So and the resultant symmetry operation of sigma xy and C2x is, so sigma xy. So applying the sigma xy to this molecule, and this molecule is in the xy plane, so it will not going to change. Am I right? It will be like that. Then what is C2x? X. So x is this. So x is this. I should take this red color. Now this is your C2. So what will happen? D, A and B. E and C will interchange their position, exchange their position. So after applying this this operation, sigma xy and C2x, you will get this molecule. Orientation of the molecule will look like this. Now the question is, which of out of these four, which operation is equivalent to this operation? So simply we have to uh, you can test, you can do operation on this molecule one by one, or you can just simply guess. Not guess, I think you final structure you know, and operations you know, so it will be easier now to get the answer. So let's try. Try to give me answer, both of you. Are you guys are you guys solving the problem or not? I think it's easy, no? See, CZ along the Z direction, if you try to rotate this molecule, all the atoms except this A will change the position. So this is not the answer. CY, so CY is this. If you change this, these will change their position. So this is not the answer because these D and B is remaining same. Sigma YZ where? So it will be like, so this will be the plane, I guess. This will be the plane. Sigma YZ, right? So in by applying this sigma YZ operation on this molecule, this D and B will change its position if you are able to see because this is along this direction. Okay. Next, what is left? YZ. YZ is, sorry, XZ. ZX. ZX is this. So this is along this direction, X direction. This is like your molecule is like this, planar. XZ is this plane. YZ was this plane. So by applying this, these two will change its position. You will get the similar orientation of the molecule. So this should be your answer. Yeah, D is the answer. Did you? Okay, both of you got. Now coming to the next question. The cyclic group among the following is. So you guys know what is cyclic groups. So even if you don't know, I have already written the definition. No, this is for the order of the group. Okay, okay. Cyclic, any idea guys? No, okay. Cyclic means by applying any operation, it has let's say C3. So C3 group. Okay. So if you apply this C3 in any molecule, so what will happen? C3 1, C3 2, and C3 3. 3. So basically, if you so C3 is the C3 is your operation. It let's say C3 1. It also contains other operation like C2, C3, and still you will get the same orientation of the molecule. So C3 1 and C3 2, C3 C3 1 is C3 1 and C3 2 is, you can write it like this. C3 1 identity. Tell me guys, you know the meaning of cyclic group or not? Oh sir. See, see the definition. Cyclic group is a group that can be generated by one element. So what I was trying to say is that, so why I've taken C3 because it was our first example. I mean first option. So C3 is the operation. Okay. Cyclic group is a group that can be generated by one element. So this is your C3. C3 is the C3 axis. This is your element which can generate a group like C3 2, C3 1, C3 3, which is identity element, or C3 inverse. So these only one element is there, which is C3. So element is your C3, right? Why? And by using this element, you can do lot of operations. I mean number of operations. So collectively, we call this group. Actually, cyclic group. So which is present in this C3. So I should this should be your answer. Okay. A. I don't know how much you guys are reading or not, so let it be like that. Just tell me you got it or not. Looks like you are not reading and have no information about group theory. Anyways, anyways. Okay. So next question is a group of order 4. What is group? Tell me now, you guys. like in the previous this here, C3 was our group in which we have lot of elements. These were your elements. Okay. So the order of a group is the total number of element it contains. So basically, if you try to count the number of what is the order of this group, just try to find out the order of this group C3. So basically, total number of elements. Order of a group is the total number of element it contains. So here I can see 1, 2, 3, or I can say this one also, or if I count this, or C3 2 inverse minus 2 something, 2 minus. So accordingly we have total will be 6. So the order will be 6, like that. I don't know this number is right or no, or wrong. Anyway, so the order of a group order of 4 means total total 4 operation elements present or operations. So cyclic you understood. So is necessarily cyclic, acyclic, can be cyclic, acyclic, is always commutative. So it does nothing. It order is nothing to do with this commutative, this quantity. So this is wrong. This cannot be the possible answer. Okay. So try to give me the answer. Is could be cyclic or acyclic, or I mean from the order you cannot tell anything. So it could be cyclic or acyclic, can be. So answer should be C number. Okay, answer is C. Shivam Patlikha, did you get it? Okay, moving on. This question you guys have to solve. The order of a group is H. So basically, total number of operation is H, and the order of one of its subgroup. Let's say C3 was present, and I said that 3 or 4 or 5 C31, C32, C33, let's say 3 elements were present there. So it is the subgroup of the point group of, I mean the order of group H. So this is the subgroup. C3 present and other, let's say C2 is also present, H sigmas is also present. So this is the C3 is the subgroup of this H. So this subgroup is H dash. Now, so here it is given H by H dash equal to P. Let's in the previous example, in the previous question, the order of the group was, what was that? 4. Now I am considering the subgroup is 2. Oh, subgroup is 2. So now tell me what could be the answer. Now it's, Shivam is saying 1 in A and B. For which A and V? For which question you are saying A and V? A and V. Answer of this one. Answer of second question. Seventh question. How it can be positive integer? Integer means 1, 2, 3, 4. So if 2 by 4 is like that, this is your p, then it will be 0.5. So how it can be in an integer? It is fraction, no? It is half. Yes. So 1 by p is 2. It will be the integer. And what about option C and D? P is necessarily an even or odd number. Cannot be say that we cannot say it can be even or yes, of course. If the order is 6 and then your subgroup is 2, then the 3 here, this 1 by p was 2, here 1 by p will be 3. So it is not necessary. So answer should be B. Yes. Did you get it? Yes. Okay. Moving on to new question, next question. A and B are the real numbers. And inverse of this is, so you guys know how to calculate the inverse. Let's say A is the matrix. Now what will be the inverse of this? Inverse of A. There is a specific formula which you should know. ATT. What is this ATT? Something like that. Okay. Nice. This is the inverse. 1 by determinant of A, adjoint of A, transpose of adjoint of A. So this is the formula of inverse. Now you know how to determine the determinant. So your matrix is A minus B, B, A. Determinant will be A into A minus minus B into B. So it will be A square plus V square. So inverse of A will be 1 by A square plus V square. Now the adjoint. adjoint matrix is matrix of cofactors of 1 1 1 2 2 1 2 2. So this the adjoint matrix of A is co is composed of cofactors. Now, how to calculate the cofactors? So, to calculate the cofactors, let's say 1 1, it should be minus 1 to the power 1 plus 1 because of 1 1 and multiplied by this. So, here is your A. So, this is your 1 1 1 2 2 1 2 2. It will give you A. C 1 2, it will be 1 plus 2, and diagonal of this 1 2 is 2 1 b to minus b. So a minus b. Next c 2 1 minus 1 2 plus 1 and 2 1 opposite of diagonal element of this 2 1 is minus b. So it will give you minus plus b. Next c 2 2. So minus 1 2 plus 2 multiplied by a. It will give you a. So diagonal of 2 2. Now the transpose of this will be, how to do the transpose? You guys know. You need to fix this diagonal element and the non-diagonal element of diagonal element will exchange their position. So this should be the inverse. Now which is the correct answer? Tell me. So these two have omitted already. These two, right? Because of plus sign. Here it is minus. So these B and D are eliminated. Now out of A and C, which one is the correct answer? It looks like C. No answer from Patlekha and Seva. Are you able to follow or got it? Did you really get it? Okay, moving on. Now moving on to assignment number 3. Okay, try to find out the answer. What is the representation of? Okay, this is written is C32I inverse. Patlika Singh, don't know sir, can you please solve? This is center of inversion. Let's say BF3. So C32. So for clockwise rotation, this is 120 degree and 240. This is 120 anti-clockwise. Clockwise, this is anti-clockwise. What is the matrix representation of product? This and this. Okay. So in last lecture, okay, this you remember, I guess. This is the transformation matrix of rotation, for rotation by angle theta along z axis. Cos sine minus sine. Okay. Cos theta sine theta minus sine theta cos theta 0 0 minus, yes. Okay. Now transformation for rotation by angle theta along z axis. So I have also taken like this. These are your axis x, y and z. So this is your operation C3 2. So the angle clockwise is, if I am considering it is clockwise, this C3 2. So 240 degree, and this transformation is for, I guess, anti-clockwise. When you rotate by angle theta along z direction anti-clockwise. So to reach here by anti-clockwise, if I don't want to change the this transformation matrix, then the angle should be 120, or I can write it like C3 minus 1. Okay, so the angle in that case should be 120. Is it making sense to you guys or not? Yes. Okay, so what will be the your matrix? Cos 120 minus 120 0 0 1 sin 120 cos 120 0 0 1, right? C3 2. Now, now you need to just uh, and the value of these what clockwise rotation. This is for anti-clockwise, right? This should be clear. Anti-clockwise. This is this transformation matrix is for anti-clockwise rotation. If the clockwise rotation you need to take, then the minus sign of these two sin theta will change, and the diagonal element will remain like this. Okay, what will be the value of cos 120 degree? Minus half 3 by 2, so minus 3 by 2, 3 by 2, minus half 0 0 0 0 1. And these values you can just simply determine from trigonometry. Okay. Now, what was our question? Question was saying what is the matrix representation of the product of C32 multiplied by inverse I. So this is your C3 matrix, C32 matrix. Now we have to multiply by inverse. So inverse means what will happen? Let's say I, X, Y, Z. What will happen? The Cartesian, the sign will change. That the that is the meaning of the inversion, right? Or let's say if you want to operate by identity matrix, then what will happen? Nothing will happen. Simple. So on this C32 matrix, this by applying the inversion, how the matrix will look like? This matrix. So it will look like minus will be plus. What else will happen? Nothing. 3 by 2, 0, minus 3 by 2, plus 0, 0, 0, minus 1. Or it should be like that. Is it clear? Okay. Then, so this should be the matrix, I believe. So let's try to find the answer. Which one is the answer? Option C. So option C is minus is here, minus is here. Other is positive. So half 3 by 2 minus 1. Yes, this is the answer, right? Okay. This is the answer. Okay. Is it clear? Okay. So moving to the next question. The next question is saying the correct statements among the following is element of an, the first option is elements of an identity matrix from form Kronecker delta. So you remember what is Kronecker delta? This I used to study in my bachelor's and master's in mathematics. 10 like this. Shivam is left. No, no, he is here. Hmm. So, what does, let's say the matrix is 3 by 3, and this is for your, of course, your row. This is your columns. So columns, these are your columns, these are your rows. So, delta 1 1, delta 1 2, delta 1 3, 2 1, 2 2, 2 3, 3 1, 3 2, 3 3. Let's say this is your 3 by 3 matrix. Now, now I am applying this chronicle delta condition. So how the matrix will look like? 1 1 will be 1, 1 2, because these two are not equal, so 0 0 0 1 0 0 0 1. So, so first option is right. Elements of an identity matrix form chronicle delta. So this is right. But the question is saying the correct statements among the following is an or. Okay, connection is lost. Hello. Okay. Anyways, okay. So first option is correct, but here other options can also be correct because this is not a multiple choice question. This is a multiple select question. So second option is a symmetric matrix is its own transpose. This is, so first you have to know the symmetric matrix. Tell me what is symmetric matrix. No, that is row and honor will be same. Number will be same. So like this 3 by 3 you are seeing. This 3 by 3. This is square matrix. Let's say this is 3. This is x, y, z. This is 3 by 1. So this is 3 by 3 is square matrix. 3 by 1. This matrix is rectangular matrix. What is symmetric matrix? What is symmetric matrix? Okay, Patlika is left. So symmetric matrix is when the off diagonal elements, let's say x, y, and z. Okay, c is back. Okay, so x, y, z. So off diagonal elements, let's say 3, 3, 4, 4, 5, 5. This is your symmetric matrix. So you need to know these definitions, otherwise it will take a lot of time. This is y, z. 3, 3, 4, 4, 5, 5. These are diagonal elements, x, y, z. This is our symmetric matrix. Why symmetric? Because A12 and A21 are same. A13 and A31 are same. A32 and A23, these are same. Element is same. That is why this is symmetric matrix. So what was our question? Symmetric matrix is its own transpose. Now you have to tell me. I have already told about this transpose. Tell me. Is option B is correct or not? Yes. Yes, option B is correct. Option B is correct. Because if you take the transpose of the symmetric matrix, again you will get the same matrix. So B is the correct answer. Now coming to what was the question, this option C. A Hermitian matrix always has real elements. Okay. This tell me what is Hermitian matrix. So have you uh, remember this Hermitian operator? If you have studied quantum mechanics, quantum chemistry, you must have heard about Hermitian operators, or you have not studied quantum chemistry. Maybe you are BSc student. So she is saying A is equal to A star. Mm, A star to conjugate. It is conjugate, right? This star is to conjugation. So why did I say Hermitian operator? Because if you remember in quantum chemistry, let's say any Hermitian operator will give you the real number. Let's say potential energy is kinetic energy of Hermitian operator. If you apply to any system, it will give you the kinetic energy. And this kinetic energy is real. It is not imaginary. Okay. So this must you have remember, maybe little bit, minus h square by 2m something. I also forget about the exact operator, something like that. So Hermitian is the property of the Hermitian. A is equal to transpose of A conjugate, or either way, this first you do the conjugate and then the transpose. So why did I say real? So in Hermitian matrix, diagonal elements must be real. Let's say 1, 2. Here, whatever you have, let's say 3i, let's say 3i, 3 plus this 3 minus i2. The diagonal elements are real. So this is the property. But off diagonal element, off diagonal element, off diagonal elements can be complex or real. This is the example. Okay. So according to this property of Hermitian matrix, if this is, so let's try to find out this matrix is Hermitian matrix or not. So this is your matrix A. Let's do the this transpose first. So how it will look like? 1, 2 will remain like this. These two will exchange their position. So right now conjugate means where is the real numbers will remain like real numbers, but the complex number will change their sign. So after applying this conjugation, what will happen? 1, 2, 3 minus i2, 3 plus i2. See here, plus was there, minus will come, minus was there, plus will come, plus will come. So after transpose and conjugation, is this matrix equivalent to your this matrix, previous matrix, the initial matrix? Yes or not? They are equal. So that is why this is Hermitian matrix, because this is the property of the Hermitian matrix, and this matrix is following this property. So this is Hermitian. Okay, matrix. Now, so let's say try to see the properties of Hermitian matrix. First is diagonal elements are real. This is the first property. So the determinant or the eigenvalue, this I already told you, I think. Eigenvalue of the matrix is real. See, here, you see, eigenvalue, eigenvalue. So basically, this operator, what is this? These operators, these are matrix only. So you will get the real, real number. Second property is that sum of any two Hermitian matrix is or will give Hermitian matrix. Same goes for product. Product of any two Hermitian matrix will give you Hermitian matrix. Fourth one is inverse of a Hermitian matrix will be Hermitian matrix. Fifth, A star will equal to A if A is real number. If A is real number. Otherwise, the change in the sign will be there. So if all the elements are real, then what will happen? Then it will become a symmetric matrix. Isn't it? See, if these were not here, these two, that is what the condition is. If all the elements are real, all the elements are real, and obviously this will go away, I2 minus I2 or plus I2. So you will get the symmetric matrix 3 3, and the diagonal element will remain there is no problem. So symmetric matrix. In that condition, what will happen? So symmetric matrix is like transpose of, this is the condition of symmetric matrix, right? This is what we have discussed in last question. So, but Hermitian matrix is A is equal to A star of T or A T of A star. A star. Yes. So all numbers are real. So conjugate will, this A of conjugate will give you A. This is transpose. So this is the condition of Hermitian, right? Hermitian matrix. So this A star, because all the numbers were real, so this condition will follow. So what will become? A of transpose equal to A. So this is the condition of symmetric matrix. That is what we have discussed in the last point here. Now tell me, is it clear? Too much? Clear. Okay. So, so what was our option C? A Hermitian matrix always has real number, real elements. This statement is correct. or not? Both of you try to solve this, try to give the answer, then we will move forward. What do you mean by no? Not yeah, of course. So this is not the correct answer. Okay, coming to fourth, adjoint of a unitary matrix. Is it inverse? So first tell me what is unitary matrix, if you remember. If you don't remember, then I'll tell. So you have to reply. Otherwise, how I would able to know? Don't remember. You must read. Looks like you are just attending my classes. You are enjoying the classes, but you are not reading by yourself. So try to watch the Anindya sir's lecture, and then come back to my class. Otherwise, you will how you will solve these examples. Have you tried these example by yourself? These assignment? No. Very good. So okay, adjoint of unitary matrix, is it inverse? So unitary matrix is A of A, this Hermitian transpose of A will give you identity matrix. So A transpose and this. So, so inverse of unitary matrix is its adjoint. Now tell me what is the answer now. Adjoint of unitary matrix is its inverse. So this is the condition of unitary matrix, right? This is. So of course, the unitary matrix, inverse of this is unitary matrix A is its adjoint. This is your adjoint. This should be your answer. Yes, ABD. Correct, correct. What is correct? I don't know. So did you get it? Okay, fine. Moving on. Hmm. ABC are real numbers, real positive numbers. This is I equal to hmm. I equal to minus root of this. I equal to root over minus 1, and D is the determinant. This is your determinant. So A, B, C, D are real positive number. So the inverse of this matrix is first you have to remember what is the inverse, how to, which I already told. Inverse of a matrix, inverse of A is 1 by this adjoint of A and the transpose, right? So try to solve it. First determine the determinant. So what will be the determinant? So determinant will be A plus, so I am writing D, A plus IV multiplied by A minus IV minus C plus ID multiplied by minus C plus ID. Is it right? Okay. Now try to find the uh, solve this determinant. So this is like a square minus I v to the power whole square, right? I v whole square minus c square, right? So a square minus I square b square I square minus I square b square minus c square. It will give you a square, and I square, you know, I equal to root over minus 1. So I square will be minus 1. So minus 1 plus v square minus, so this is minus 1 d square plus c square, because I am now opening the bracket. A square plus b square plus d square plus c square. So they have given, anyway, they have given the different determinant in the question. So we have find found out this determinant, value of the determinant. Okay, now try to find out the adjoint. So how to find the adjoint? First, start building the cofactors. C11 minus 1 plus 1. What is the opposite to this, diagonal to this 1 1? It's this A minus IB. So it will give you A minus IB, then one C12 minus 1, 1 plus 2 in bracket minus C plus ID, right? We are finding for this one. Now 2 1 minus 1, 2 plus 1 in bracket C plus ID. Now for C22 minus 1, 2 plus 2 A plus IB, right? Now try to build the matrix. So C11 A minus B IB, C12. So here will be minus this. So I C minus ID. Next 2 1 minus will be here. So outcome will be minus C minus ID. Next uh, minus 1 to the power 4. So A plus ID. IB. IB. Now we have to do the transpose of this. So the transpose of this will be A minus B, A plus I. These two will change their position. I think, and then the full inverse of, okay, so the inverse of A will be 1 by D and this matrix. So try to find out the answer. Here I can see 1 by D is everywhere, so this is not a problem. So first element 1 1. First element is A minus 1, A minus IB. A minus IB I am not seeing in any of the answer, in any of the given option. Okay, there must be something wrong here. Okay, anyways, you know how to do it. So what is the answer? A. Okay, our answer is not matching. So anyway, maybe the question is wrong or something, but you know the procedure. So I think that's not a problem. So we can move forward. Got it, sir. Okay. So let's move to this question. The next question. So here maybe question is wrong. I guess the matrix is wrong, or option is wrong. Something is wrong here. Anyway, moving to this question. Question number 4. A matrix is singular when its determinant is necessarily. This is the definition of singular matrix. So I've actually wrote it down here. A singular matrix is a square matrix whose determinant is exactly 0, which means it does not have a multiplicative inverse. This condition occurs when, so basically of singular we don't singular matrix doesn't have its inverse matrix, because for inverse matrix we have to, because when we determine the inverse matrix there is a 1y determinant factor come. So determinant is 0, 1y 0, so you cannot determine the inverse of singular matrix. See, this will go 0, this goes 0. So inverse of the singular matrix cannot be determined. Okay. This condition occurs when the matrix row or columns are linearly dependent, meaning a row or column can be expressed as a combination of other. Okay. So I think you must remember if you have studied this matrix. Let's say 1, 2, 3, 1, 2, 3, and 4, 4, 5, 6. What is the determinant of this matrix? Tell me. Is it zero, non-zero, or just by looking? I mean, my first question would be, uh, are you guys able to determine, or is it possible to determine the determinant of the matrix without calculating by just looking at the matrix? Is it possible or not? Uh, okay, no, actually it is possible by looking at the matrix. So by looking at the matrix, you can determine the determinant of the matrix. That determinant is zero or not, non-zero. That is what I am saying. So if two rows or two column of the matrix of any matrix is same, are same, then the determinant of the matrix has to be zero. So that is what it is written here. This condition occurs when the matrix row or column are linearly dependent, meaning one row or column can be expressed as a combination of other. In other words, I would say 1, 2, 3 and multiplied by 3, let's say 3, 6 and 9, then 4, 5, 6. This is matrix A, this is matrix B. Tell me, what is the determinant of matrix B? Non-zero. Actually it is 0. Meaning one row or column can be expressed as a combination of other. So this row, this column, if you take out 3 or divide this matrix, this column by 3, so how it will look like? 3 will come out. Okay, and 1, 2, 3, 1, 2, 3, 4, 5, 6. Again, this B matrix is looking like B is equal to 3 of A, correct? Which means the determinant of this is also 0. Basically, that is what it is written here, meaning one row or column can be expressed as a combination of other. So this column was expressed as a combination of this and multiplication of 3. So this is your singular matrix. Answer is 0, which I will, in a sense the matrix fails to represent a unique transformation, leading to scenario that like the absence of a unique solution for a system of linear equations. Anyways, so this is your answer. A, yeah. When determinant is necessarily 0. Okay. Okay. Okay, moving to new question. New question. Unitary transformation of a unitary matrix always gives a matrix that is. Tell me what is the answer. It's like unitary matrix, just like the Hermitian matrix. See, some product inverse will always give you the Hermitian. Similarly here, unitary transformation of a unitary matrix always gives a unitary matrix. Okay, moving to next question. Is it clear, guys? Question number 5. Yes. Okay, now of the following, 5 is done, no? Huh. Of the following, the quantity that is not an eigenvalue of this is. Tell me how to do it first. Just think for a minute and then tell me how to determine these eigenvalues. Of the following. Okay. Looks like there is no response, so A minus lambda E give you 0. So that is your character equation. So here the lambda is your eigenvalue. This is your eigenvalue. And E you know already, identity matrix. A is this matrix, given the matrix. So you have to find it out. Anyways, is that a cos theta sin theta 0 minus sin theta cos theta 0 0 0 1 minus lambda 1 1 1 0 0 0 0 0 0. So it will be like cos theta minus lambda sin theta 0. Okay, in the next page, cos theta lambda sin theta 0 minus sin theta cos theta minus lambda 0 0 0 1 minus lambda, so is equal to 0, and determinant of this is like a minus lambda e is equal to 0. Now you have to solve this to find the determinant, to find the eigenvalue. So it will be like cos theta minus lambda and rest this cos theta minus lambda 0 0 1 minus lambda. So this is because here is also determinant is there. Okay, now minus sin theta. This is how you find the determinant. Minus sin theta 0 0 1 minus lambda plus 0 multiplied by this minus sin theta cos theta minus 0 0 this is equal to 0. So this is how you determine the determinant. Okay, now solve it. Cos theta minus lambda cos theta minus lambda, this I will take in the bracket, minus multiplied by 1 minus lambda minus sin theta in bracket minus sin theta multiplied by 1 minus lambda and 0. This is 0 equal to 0. Okay. So cos theta minus lambda whole square 1 minus lambda minus minus plus sin theta square minus 1 minus lambda equal to 0. 1 minus lambda cos theta minus lambda whole square plus sin theta square is equal to 0. So 1 minus lambda, if this is 0, then the whole equation will come out to be 0. So lambda could be 1, or this could be, and if this goes to 0, then we have to also find out. So cos square theta plus lambda minus 2 cos theta lambda plus sin square theta is equal to 0. So this is equal to 1. Lambda square minus 2 cos theta to lambda plus 1 equal to 0. So try to find out the roots. Minus b plus minus root over What is the formula? B square minus 4AC divided by 2A. So what will be the lambda? Minus B means minus minus plus 2 cos theta. Okay. Plus minus root over. So 4 cos theta square minus 4A is 1, C is also 1. So 4 divided by 2 into A1. There. So try to take out this 4. Here you will left 1, 2 will go. Okay, so lambda equal to cos theta plus minus uh, sin theta divided by 2, because this will turn out to be cos theta square minus 1 ka whole square. So it will be like sin square theta root over sin square theta. So it will be sin theta. Okay. 2 will not be here. Okay, it will goes out. 2 will not be here. Okay. So what is the answer? Oh, we made some mistake. I was here. Oh, okay. Ask questions if you are not able to understand. Looks like we are making some mistake, or the answer is also D. Here they have the question is asking that the quantity that is not an eigenvalue. So minus 1 is not the eigenvalue. Other three are the eigenvalues. So this we have got. This we have got. I is missing in option B and C. I is missing in our answer. Any idea, guys, where we are making mistake or? Not able to find it, but let's see. Okay, Shivam is saying cos square theta minus 1 should be minus q square sine theta. Huh? Is it? Sine square theta plus cos square theta is 1. So cos square theta minus 1 plus sine square theta equal to 0. So cos square theta minus 1 equal to minus sine square theta. Yes. So here we are making mistake. This is the mistake. Okay. So, so basically this portion will be like root over cos square theta minus 1 will give you minus sine square theta root over. So root over 1 and this sine theta, which is min I sine theta. So here the I will come. Nice. Nice, Shivam. So answer is this. These are these these are the eigenvalues. So the answer of this question is D. Now is it clear? Patlek, are you got it? Okay, Patlek, are you able to follow? Yes, sir, got it. Nice. Okay, moving to the next question. A and B are the real positive numbers. Inverse of this you guys must do. Tell me the answer. This you should do. Okay, let me help you how to find the inverse. Now figure it out. Okay, Shivam is saying A and C. Okay, two answers. Should be one answer. C only. C only. Okay. Shivam said, what about Patlekha Sarkar? C. Okay, nice. Let's see the answer. My screen is not moving, so I don't know what to do with this. Okay, nice. Perfect. Answer is C. Okay, moving to the next question. 8. This is also simple. Tell me. Adjoint of matrix A. Adjoint of, let's say, A. Cofactor 1 1, cofactor 1 2, cofactor 2 1, cofactor 2 2. This will be your adjoint of A. Now to determine the cofactor, C11 equal to minus 1 to the power 1 plus 1 and A 2 2, like this. Tell me what is the answer. Okay, nice. Shivam is saying B. Patlika is also saying B. Okay. Okay, nice. Perfect. Moving to the next question. Ninth. Eigenvalues of this matrix includes. So just now we have solved how to find out the eigenvalue of the matrix. Okay, we have 5 more minutes to finish this class. 1 hour 54 minutes, 55 minutes. So 5 more minutes. We have to solve this example, this question in 5 minutes. Okay. Since you guys are not replying, let me help you. Okay. So one thing is also, if the matrix is 3 cross 3, there will be 3 eigenvalues. So if the matrix is 2 by 2, 2 eigenvalues will be there. Like in the previous example here, the matrix was 3 by 3, 3 by 3. So we got the 3 eigenvalues. Okay, moving on. Same thing. For 2, 1, 4 minus I, 4 plus I minus 14. So it is like A minus lambda E equal to 0. So minus lambda e will look like e is 1 1 1 0 0 1 0 0 0 this, right? So minus lambda is just a multiplication of minus lambda into this I. So minus lambda e will look like lambda minus lambda minus lambda minus. So then if you try to find out the a minus lambda e, then diagonal element will be 2 minus lambda 14 minus lambda is equal to 0. So this is 3 cross 3 I have made. You just consider this 2 cross 2 for this example only. Okay, so it will look like this, right? Then you have to find the determinant of this 2 minus lambda multiplied by minus 14 minus lambda minus 4 minus I multiplied by 4 plus I equals to 0. So it will be 2 minus lambda minus 14, 2 minus lambda minus 14 minus lambda minus 4 minus, so this is 4 minus I multiplied by 4 plus I equal to 0. Yes. So it will be like minus 28 minus 2 lambda minus plus 14 minus 14 lambda plus lambda square. Here minus 4 square minus I square is equal to 0. So it will be like 4 lambda square. It will turns out to be 12 lambda plus minus 28 minus 16 and I square is equal to minus 1. So this is minus 1. So it will be minus minus plus 1 is equal to 0. No, this should be plus 1. So here it will be minus. So lambda square plus 12 this minus, we are making some 29, 16, 45 is equal to 0. So try to find out the value of this minus b, 12 plus minus b square 144 minus 4 a is 1 and c minus 45, 2 into a, so 1. Now these are your values. Try to solve this and then you will find 144 multiplied by 90, 180. 180 is plus, divide by 2. How much it will come? Plus minus root over 40, 36. Right? 2. So minus 12 plus minus 6 divided by 2. So in one case it is plus, so 12 plus 6 by 2 is equal to 6 by 2 is equal to 3. In one case minus 12 minus 6 divided by 2, 18 minus 2 divided by minus 9. Oh, we did something wrong. This is addition, not the minus. So this is 324. This should be 324. Anyways, you guys can do the math. Let me do the math. Lambda equal to minus 12 plus minus 324 divided by 2. So in one case, lambda 1 minus 12 plus minus 334. The root of the 334 is 18, I guess. Huh? Uh, Yes, 18. So it will be 18 by 2. So lambda 1 is minus 12 plus 18 divided by 2. Lambda 2 is minus 12 minus 18 divided by 2. So 6 by 2 here, 30 by 2 minus 3 minus 15. So these two are lambdas, eigenvalues. Okay. Minus 15 and 3. A and C, yes. Why, okay. Shivam is saying why vanishing methods are no need to apply Sridhar Acharya. Yes. What is vanishing method? What is vanishing method? You have to tell me. Okay, Patlekha is already left. She is done for the day. Okay, looks like Shivam is not replying, so we should close our session here. It's already 2 hours, so 2 hours 5 minutes. Nice. You can speak also. Okay, okay, okay. Oh, okay, okay. Got it, got it. Okay, okay. I got it. Basically, the you have to break this B. So the multiplication of this and this will be similar. Not similar, same. So lambda square plus 12b minus 45 equal to 0. So lambda square minus 15 plus 15 minus 3 lambda minus 50 is equal to this 45. So then the answer will be minus 15 plus 3. So here the plus 15 and minus 3. Anyways, okay, I'm closing the session now.